Giant students, welcome to my YouTube channel. Students, a man is not so much the slave of his fellow man as he is of his own inferiority. What I mean to say is that get rid of your inferiority complex. That is, think yourself greater than others and you will feel yourself to be greater. You will actually feel yourself to be greater than others. So students, with that, let's begin our session. In the previous lecture, we have started with the important topic of projectile motion. So continuing with that, today we are going to discuss the case 1. That is the case of horizontal projection. That is, when a body is imparted some horizontal velocity from a height. We'll prove that in this case, the path followed by the projectile, that is the nature of its trajectory is parabolic, will mathematically verify it. We'll try to find its expression for the time of flight, we'll find the expression for the range, and we'll also try to find the expression for the net velocity with which the projectile strikes the ground. Right? So students, let's deal with this particular case. This is suppose a building and this is the ground. This is suppose a building, say of height h. It's a building, say of height h. And let us assume a body from height h is imparted initial velocity u. It is imparted initial velocity u. So it is the case of horizontal projection. So we are going to prove that it will follow a parabolic path. So it will tend to follow a path like this. Right? Okay. So as we are aware students, let's recall the concepts involved in a projectile. Any body which is thrown in air or space and whose motion is only and only under the influence of gravity, that body may be termed as a projectile. We have discussed students very important points that projectile possesses two independent motions. One is the horizontal motion, the other one is the vertical motion. Look, we have considered, or rather we have assumed that air resistance to be neglected, the acceleration due to gravity to be constant throughout the motion of the projectile, then the effect due to the rotation of the earth is neglected, the effect due to the curvature of the earth is also neglected. So while deriving articles or while deriving certain expressions, we'll assume all these things, right? So basically students, in the horizontal motion, the projectile will be under the influence of balanced forces. That is, no net force acts on the body. Therefore, acceleration on the projectile along the horizontal direction would be 0. Acceleration 0 means velocity along the horizontal direction will remain constant. So along the horizontal direction students, at any point during the motion of the projectile, the velocity must remain same. So at any point, suppose this is the point, the horizontal velocity will remain same. This is it. So I have drawn these arrows all of equal lengths. So horizontal velocity will remain same. This is the initial component of the horizontal velocity along the x direction. This is the final horizontal component of velocity. Again, it will be u only. So Vx is equal to ux is equal to u is equal to constant. No doubt regarding this, right? Since Ax is equal to 0. So along horizontal direction, in the absence of any net force, acceleration is 0, therefore velocity of the projectile along the horizontal direction will always remain constant, right? So this is the first type of motion, which is the horizontal motion. Second student, a projectile possesses vertical motion as well. And when I talk about vertical motion, then obviously a body during its motion will always be under the influence of force of gravity, as a result of which it will get attracted towards the center of the earth. So due to this force, the body will get accelerated and the acceleration will be g, which is the acceleration due to gravity, small g, 9.8 meter per second square. So when the body is coming downwards, then what happens? The vertical component of the velocity due to this acceleration will keep on increasing at this constant rate of 9.8 meter per second square, right? So initially the body is given only horizontal velocity. So initial vertical component of velocity is 0. But as it is coming towards the surface of the earth, due to the acceleration due to gravity, the velocity, its magnitude along the vertical direction will keep on increasing at a constant rate. So here there will be finite value of the vertical component of velocity. Here the vertical component of velocity will further increase, and at the instant when it strikes the ground, the vertical component of velocity would be maximum. Suppose Vy is the final vertical component of the velocity of the projectile when it strikes the ground. Clear, students? So as you can see here, Uy is 0. Here it has got some finite value. Here the vertical component of velocity is further increased, and here the vertical component of velocity is maximum. So the vertical component of velocity of the projectile keeps changing at a constant rate. Here since it is coming down, so it will keep increasing at the rate of 9.8 meter per second square, right? So a projectile possesses these two independent motions, horizontal motion and vertical motion. Clear? Okay. Now what we do is, as I have told you, the resultant velocity of the projectile at an instant will be given by drawing a tangent at that particular point. And the resultant velocity will be the vector resultant of the horizontal component of velocity and the vertical component of velocity. These two are at right angle. So the resultant velocity would be like this. It will be given by drawing this parallelogram. So these are the two adjacent sides of the parallelogram. So the resultant will be given by the diagonal of the parallelogram. And here the diagonal of the parallelogram at that point will represent the net velocity of the projectile at that point. Right? So at this instant, the resultant velocity with which it strikes the ground would be like this. This is the resultant velocity. This is supposed represented by VR vector. Right? This is the resultant velocity. So this obviously would be the parallelogram. And these two are 90 degree, obviously. So VR in magnitude over here, it will be definitely given by square root of Vx square plus Vy square. This is the resultant velocity with which the projectile will strike the ground. Anyways, we will discuss it later on. Now first, let's find out the equation of trajectory of the projectile, right? For that, what we assume is, suppose initially the body is at this particular point. This is point A. Suppose at some later instant, at t equals to t, body is at point B, and at t equals to capital T, the body is at point C. Capital T, students, remember, it is the time of flight. That is, it is the time during which the projectile remains in air or space, right? So, during time small t, the projectile has covered this distance, right? It has covered, suppose, horizontal distance x and vertical distance y. This is the vertical distance y, and this is the horizontal distance x. So what we have considered is, from A to B, this is point A, this is point B. From A to B, in time small t, the projectile has covered vertical distance y and horizontal distance x. So let's find out an equation relating x and y. That will be our equation of trajectory, right? Okay, let's proceed. So first and foremost objective is to find out equation of trajectory. Equation of trajectory. So for this, consider motion of the projectile from A to B. This is very important to mention. A is considered to be the initial point, B is considered to be the final point. A to B, right? Now, along horizontal. Now, using second equation of motion, Sx equals to uxt plus half ax t square. In time t, in time t, the body has covered x distance along the x direction. So x is the displacement along x direction. What is ux? U is the initial velocity. X means it is the initial velocity along the horizontal direction. And the entire velocity is along the horizontal direction, which is u, isn't it? So it is u. Time is t. I have told you very often, along the horizontal direction, the projectile won't experience any force. So net force along horizontal direction is 0, therefore acceleration along horizontal direction is 0. So what you get is x equals to ut, or t is equal to x by u. Put this as equation number 1. Clear? Now let's consider along vertical. Okay, again let's make use of second equation of motion along the vertical direction. Sy. In time t, the distance covered by the body along the y-axis, that is y. Uy. Initial vertical component of velocity is 0. Initially, the projectile possesses only the horizontal velocity. It is given horizontal velocity, right? So initial vertical component of velocity is 0. This is uy, which is 0. Plus half. The body is coming downwards towards the earth. So ay would be plus g. I have told you projectile is having another motion, which is the vertical motion, which is under the influence of gravity. A is minus g when it is going upward, and A is equal to plus small g when it is coming downward, right? So what we get is y is equal to half g t square. Now students, we can make use of equation 1 and 2, and we can substitute the value of t from equation 1 in equation 2. That will give us the equation of trajectory. Therefore, from 1 and 2, what we get is y is equal to half g, t is x by u, so what we get is x square by u square. This is, student, the equation of trajectory. Now, the important point to be noted down over here is the term inside bracket is constant. Acceleration due to gravity throughout the motion of the projectile is considered to be constant. U is the initial velocity, which is constant. So half is constant. So y is proportional to x square. This is the standard equation of a parabola. Now, the equation for the trajectory is in accordance with the standard equation of a parabola. So students, we have mathematically proved that when a body is imparted horizontal velocity from a height, then it follows a parabolic path. That is, the nature of trajectory of a projectile is parabolic. So nature of the trajectory of a projectile is parabolic. This we have proved, right? And this is the equation of trajectory, right? Now students, we will try to find out the expression for the time of flight. So let's do it. Expression for time of flight. For that, we need to consider motion from A to C, because the total time during which the projectile remains in air or space, that is known as its time of flight, right? So, expression for time of flight. It will be represented by capital letter T. So what we'll do is, we'll try to express T in terms of h. So consider motion from A to C. A is the initial point, C is the final point. And during this time, capital T, the body has covered a vertical displacement of h. Again, along vertical direction, if you consider second equation of motion, why we are considering along vertical direction? Because we need to find an expression for capital T in terms of the height of the tower or height of the building. So h is the vertical height. That's why we are considering the equation along the vertical direction, right? So in time capital T, the body has covered h vertical distance. Sy is the distance covered by the body in the vertical direction. So it is h. From A to C, the body has covered h vertical distance. What is Uy? As I told you just now, Uy is 0 because this is the case of horizontal projection where the body is given or imparted horizontal velocity. So initial vertical component of velocity is absent or it is 0. Half Ay, it is coming downwards, so Ay is plus g. Small t, A to C, total time taken is capital T. Right? So simply rearrange the terms, what do you get? T is equal to square root of 2h by g. This is, students, the expression for the time of flight. This is the time during which the projectile will remain in air or space, right? Okay. Next is, let's find out the expression for the range. Range will be given by r. This is the range. This is the range, right? So, in order to get the expression for range, we'll consider motion along horizontal. So, let's consider along horizontal direction. And again, we are considering the motion of the body from A to C, right? Along horizontal from A to C. Look, Sx is equal to uxt plus half ax t square. Sx, from A to C, the horizontal distance covered by the projectile is r. Ux, initial velocity along x direction, that is u, which is constant. Small t, from here to here, the total time taken by the projectile is capital T, which is the time of flight. Plus half, acceleration along the x direction is 0. So therefore, r is equal to u into capital T. So u, capital T we are already aware, it's square root of 2h by g. So this is the expression, or rather the formula for the range in the case of horizontal projection. Clear, students? Simple. Last is, students, we need to find out the expression for the net velocity with which the body strikes the ground. As I told you, the resultant velocity would be the resultant of these two perpendicular velocities, the horizontal and the vertical component of velocity. Both are at right angle to each other. So whenever the two vectors are at right angle to each other, the resultant, its magnitude is given by square root of a square plus b square. That is what I've used over here, right? So here what we do is, let's substitute the value of Vx and Vy. Now look, students, Vx, we are aware, Vx is equal to Ux, Vx is equal to Ux is equal to U. It is equal to constant. This we are already aware. No doubt regarding this. There is no change in the horizontal component of velocity. It will remain constant throughout the motion of the projectile. So, Vx, V is the final velocity along the x direction. It is equal to the initial velocity along the x direction, which is equal to U. Right? So, Vx is equal to U. Now, let's find out Vy. So, in order to find out this Vy, we have to consider motion from A to C. We have to consider motion from A to C, right? And let's consider first equation of motion. Vy is equal to Uy plus Ay. So Vy is to be found. What is Uy, students? Initial velocity at point A along the vertical direction is 0. Plus Ay, it is coming downward under the influence of gravity, so Ay is plus g. And small t, from A to C, total time taken by the body is capital T, which is time of flight. So Vy is equal to g into capital T. Capital T is the time of flight. So students, you can substitute the Vx, value of Vx and Vy over here. So the resultant velocity, its magnitude, when it strikes the ground is given by square root of u square plus g square capital T square. So this is the expression for the velocity with which the projectile strikes the ground. Right? This is the magnitude. And students, what about the direction? Suppose it makes an angle beta. Suppose the resultant makes an angle beta with the horizontal. This is the case basically. This is horizontal. This is u. This is the resultant VR. And this is the vertical component Vy. Suppose this is angle beta. This is angle beta. So we can find out the direction of the resultant velocity as well, isn't it? So what to do is, this will be a right angle triangle. This will be a right angle triangle. Consider, and this is a parallelogram, so opposite sides are equal as well as parallel. So consider tan beta. It will be equal to Vy divided by Vx. This is Vx. Clear, students? Therefore, beta, it would be equal to tan inverse Vy, it is equal to Gt, divided by Vx, it is equal to u. So this is the expression for the angle which the resultant velocity makes with the horizontal when the projectile strikes the ground. So students, these are the various expressions. So we have discussed the equation of trajectory, the time of flight, and then obviously the range, and lastly we have also found the net velocity with which the projectile strikes the ground. Students, what to do is, just to recapitulate all these formulas, let's try a numerical, a simple numerical, right, based on this particular case of horizontal projection. So what we consider is, suppose this is a building, maybe of height 490 meter, and from the top a body is imparted velocity of 98 meter per second. Right? So obviously, just now we have discussed, it will naturally follow a parabolic path. The nature of trajectory of a projectile is parabolic. Here in this case, suppose we are supposed to find out the time of flight, the range, and the net velocity with which the projectile strikes the ground. These are the three things which you are supposed to determine. So let's do it. Now, after doing the article, students, you need to remember those formulas, right? So here, while dealing with numericals, we'll directly apply those formulas without bothering for its derivations. So first is time of flight. Time of flight, we are aware, it's given by square root of 2h by g. These are the formulas which are valid only in case 1, that is when the object is projected horizontally from a height. So, 2, height is 490, g is 9.8, right? So it will be equal to square root of 980 divided by 98 into 10. 98 get cancelled, so we'll get 10 seconds. So this is the time of flight. So total time during which the projectile will remain in air or space would be 10 seconds. Very simple, isn't it? Now second, let's find out the range. Range is, students, u multiplied by t. Just now, previously we have done this, isn't it? U is the initial velocity, so that is 98. Time of flight is 10 seconds, so it will be equal to 980 meters. So very simple, right? So range is 980 meters. This is the range. Now let's find out the resultant velocity with which the projectile strikes the ground. So third part. This is, students, square root of u square plus g square t square. So it will be equal to, u square is 98 square plus g square 9.8, t is 10, whole square of this. So what we get is square root of 98 square plus 9.8 into 10, again we will get 98 square. So it would be equal to 98 root 2 meter per second. Clear, students? And also, since both the components are same, isn't it? So to make an angle of 45 degree with either vertical or horizontal, I'll show tan beta. It is equal to GT divided by U. G is 9.8, it is 10 divided by 98. So it is equal to 1, isn't it? So therefore, tan beta is equal to tan 45 degree, which clearly suggests that beta is equal to 45 degree. So that's the direction. Without doing calculation, you can directly predict, because whenever the two vectors are of equal magnitude, then the resultant always bisects the angle between them, isn't it? So here, this is Vx, it is 98 meter per second, and this is Vy, it is also 98 meter per second. So this angle which it makes would be 45 degree. The resultant will bisect the angle between these two. So if these two are inclined at 90 degree, the result will make an angle of 45 degree with either Vx or Vy. Right, students? So I hope you have enjoyed this session and you have understood this case 1. Clear? You must be feeling confident about this topic of projectile. So that's it for this session. Do join me in my next lecture. Till then, bye bye. Take care.